Creating these classes requires equipment and services that cost money. If you appreciate this education, please think about going to elithecomputerguy.com and offering a one-time or monthly recurring donation. Welcome back. As you know, I am Eli the Computer Guy, and in today's class, I'm going to give you an overview of the track for programming and for coding. So a lot of people out there nowadays, they hear programming, they hear coding is the way to make money, which is absolutely 100% true, but they're a little bit confused about what the field looks like when we're talking about coding, when we're talking about programming. What are we talking about and how do you get involved with it? So that's what we're going to be talking about in today's class. So the first thing that we need to talk about is the basic idea of what is coding, what is programming. Now, essentially, when we talk about coding and we talk about programming, those are words that can be flip-flopped around. So somebody who is doing coding is doing programming, and somebody who's doing programming is doing coding. In some instances, it might be a little bit more specialized in that, but basically programming and coding, whenever you're talking about this, a coder or a programmer, more or less is synonymous. So the first thing that we need to talk about is basically what are you doing when you are programming or when you are coding. All you are doing when you are programming or when you are coding is you are telling a computer what to do. Right? So basically what you're doing is you're writing out instructions to tell a computer what to do in specific circumstances. So if somebody clicks a button, you want an email to fire off, or you want an HVAC system to turn on, or you want a document to be printed. If somebody goes and opens up your particular piece of software, you want to tell the computer how that software should operate. You're going to code that software. So a very simple application that you may create is something like a basic calculator, right? Somebody types in numbers, they type in an operator. So an operator would be a positive, a plus sign, a negative sign, a divided by, or a multiply. So you type in a number, 2, you type in plus 2, you hit equal, and then you want your little application to add those two numbers together and pop out 4. 2 plus 2 equals 4, right? And so that is where you're going to write out how you want that to function. You may think about a more complicated piece of software that you may write, such as a piece of invoicing software, where the invoicing software actually looks a lot like that calculator that we just talked about. So what you do is you put in the different items that you have in your inventory. So maybe a calculator costs $2 and a pencil costs $1 and a pad of paper costs $3. So if somebody comes in the store and they purchase 3 calculators and 2 pencils and a couple of pads of paper, what can happen is basically you type into the computer, or you select in the computer that these items are being purchased, and then this invoicing piece of software will then figure out what the quantity is, figure out what the price is in the system, then create a total, print everything out so the customer can see it, and then you can actually take money from the customer and say that the invoice has been paid for. Beyond that, when we start talking about coding and programming, something that I get very interested in is you can start doing things where you can start manipulating systems within your environment. So one of the things I like to play with a lot nowadays is Arduinos, right? So Arduinos are these little, they're called microcontrollers. And so with these microcontrollers, what you can do is you can add sensors to these microcontrollers. So you can add temperature sensors, light sensors, motion sensors, just about any sensor you can think about, you can add to one of these microcontrollers. And then what you can do is you can write code for these microcontrollers that say, when this sensor senses X, Y, or Z, then I want an output to happen. Right, so let's say one of the projects that I do a lot for elithecomputerguy.com is I use a lot of the temperature sensors, basically little temperature demonstrations. So basically what you can say is if the temperature gets above a certain degree, so if the temperature, let's say, gets above 90 degrees Fahrenheit, turn on a red LED. Else, you can do an else. So basically, if it's under 90 degrees Fahrenheit, turn on a green LED. So basically, if the temperature is too high, the light is red. If the temperature is too low, or is lower than being too high, the light is green to tell you how the temperature is. You can also do things, again, with code, is you could actually fire off things in order to have things such as notification emails sent out. So if the temperature goes above 90 degrees Fahrenheit, turn on the red LED and send an email to whoever the administrator is, right? So basically what you're doing is you're typing out all of these commands. We'll learn about this later, something called if-else statements. Basically, if this condition is true, do this, else do something else. And the cool part is you can do a lot of interesting things with coding in ways that you previously couldn't. So a lot of you out there may be thinking, hey, I've been watching Eli, the computer guy, for a long time. He's done some coding videos. He's done some coding classes in the past, but he has not been a big programmer. He's kind of been a little poo-poo on the programming thing, really, if you've been watching my videos over the past 10 years. Why is he getting into programming now? Why is he starting to talk more about coding now when he didn't really talk a lot about it in the past? Well, one of the things to realize is in the technology field, everything evolves, everything changes, right? So I got into IT, basically IT, like MCSE type stuff, about 20 years ago. And so 20 years ago, what you had the systems folks, right? You had the MCSE and the Linux system administrators and maybe the Cisco people, right? And they were over here. And then you had the developers, and they were over here. So basically, if you're a systems person, if you're an MCSE, something like that, you took whatever the developers gave you, however it was, whatever condition it was, whatever quality it was, and then you try to implement it into the real world. And the reality is basically there is a massive big wall between the developers and the operations people, basically the IT. So the help desk people, the desktop support people, the systems people, right? There was a big wall. Even if your company had developers, right? Basically they had in-house developers, chances were the operations people, the IT people, had no idea who the hell those developers even were. Like, it is really hard to explain 20 years ago how much of a wall there was between the developers and the operations people. Basically, the developers handed you a product, and as an IT person, it tried to make the damn thing work, right? Well, the thing is, time has gone by, things have changed, and the way that we do architecture now has changed. So back in the old days, we had something that was called a client-server architecture. So you had servers, and servers were things like Exchange servers, web servers, let's say SharePoint servers, whatever else. Basically, it was a computer that was dedicated to providing services to client computers, and then you had the client computers. So you would have, let's say, a Windows NT server, and then you'd have a Windows NT workstation, right? In that environment, the server had specialized software installed on it. So you had a server that had an operating system that had specialized software installed on it. It had all the configurations for how it was supposed to provide services to the client computers. And then the client computers, they would have the operating system, they would have their client software installed on it, and then they would have the configurations to connect to the servers, right? So that's basically how things were before. And so the developers, the programmers, the coders, they would develop server software, client software, whatever else. They would pass it over the wall. We would get it. We would look at the instructions. We'd scream. Oh, we do a lot of screaming. And then we would try to deploy it into the world, right? But an important thing to understand about the client-server architecture is, again, that was a server. So the Active Directory server, you knew the physical box Active Directory was running on. The Exchange server, you knew the physical box the email server, the Exchange server was running on, right? You knew everything. You could touch everything. The server and the services that server was providing, everything was one box that the systems folks were responsible for, right? And so one of the big things with IT back in the day is when the developers passed over a product to the operations people, to the IT people, we just kind of had to deal with whatever crap that we were given. And a lot of times it was crap. Well, now we have gone to something called a service-oriented architecture, or even a serverless architecture. So now, instead of IT people having to focus specifically on specific machines, so this is a server with a hardware, with an operating system, with the software installed on it, with all the configurations, now we're just dealing with services. So think about things like Box. Think about things like email services now, like with Gmail, right? So with Gmail, I know my company uses Gmail in order to send and receive emails, but I'm now no longer responsible for the machines themselves. I'm no longer responsible for an Exchange server, right? So if you use Office 365 and you use the online version of Exchange, right? You don't know what the database configuration looks like. You don't know what operating systems those Exchange servers are running on. You have no idea what the actual architecture for the email system looks like. You simply know that your client systems, your client computers, are able to connect to what is being provided by Office 365, and they now receive the service from Office 365. Well, that's what we start talking about with a service-oriented architecture, where we are now getting services from different vendors, from different providers. They may be public providers, things like Gmail, things like Box, different services from AWS or GoDaddy or Azure, or they may even be local services. I actually may have a machine that is providing like DNS or DHCP or other services, but I'm no longer looking at the services that are being provided as if it's a server. I'm more looking at it as a service. Well, that's where we start to get to some very interesting things, especially as IT people, right? So if you start to go now, and if you look at service-oriented architecture, and then you look at the new world of something called serverless architecture, what's really cool is you go to companies such as Azure, Microsoft Azure, or you look at AWS services, and they're starting to have services being provided that are much more powerful than anything that you would even run on your own local servers. So if you go over and you take a look at something called cloud, it's Azure functions. So you may hear about cloud functions, or if you're dealing with Microsoft Azure, they have something called Azure functions. If you look there, there's some really awesome stuff out there. There's machine vision, basically Azure functions. So you can create code, and that code will then send pictures to the Azure machine vision function that they've created, and then that function will then give you back things such as tags about what is in the image, right? So basically you have this whole pile of images. You want to know what's in this whole pile of images, so you're able to send them up to the Azure functions. The Azure function is able to then look at what's in the images and then give you what the results are. And so we're now dealing with a world where we're no longer, as IT people, focused on the servers, focused on the hardware. We are now becoming more and more focused on the idea of how am I able to solve problems with this serverless architecture, with these services that are available. And so now what's happening, instead of in the old days, what was important for IT people is the IT person had to know how to connect a client computer to a domain controller in order to make that client computer a part of the domain. Now it's becoming more things such as trying to figure out systems for things such as like a notification systems. Again, so if I have this sensor out in the field, how can I write code to then route notifications appropriately based off of certain circumstances? So back in the old days, right? Back in the old days, let's say we had a file server. That file server would have a quota on it, so you could only store so much data on the file server. And if you get above a certain limit, then it was able to fire out a single email or fire out an email to whoever the administrator was. So if I'm the administrator for this file server, it would then send out an email if the storage is almost full. When we think about the modern world, how useful is that? I mean, it's more useful than not getting a notification. But wouldn't you want those notifications to be routed the most appropriate way? So basically, whoever is currently on duty, not only whoever is currently on duty, but possibly whoever is most experienced on that particular system. So what you can do now is you can write code for a notification system that will then go and it will actually look at who is currently on duty. Then out of who is currently on duty, it'll see who is most experienced. And then out of who is most experienced, it can actually see who is most experienced in this particular system, who maybe has the rights and administrative privileges and all that kind of stuff. And then you can actually route notifications based off of that. So if the hard drive is full, then you go through, search for whoever is currently on duty, Out of those people, determine who has the proper administrative rights and privileges for this particular machine. Out of those people, figure out who is maybe most geographically close or something else. Then, basically with that, then fire off a notification to that particular person. And so why coding is very important today, and why I'm talking about coding today, is because the world of coding has changed. It's no longer this world where developers are over here and operations people are over here. And the fact of the matter is, you might run into the people at the coffee machine and you don't know who is who. Literally, that's how the world was before. We are now in a world where operations and developers are literally working side by side. There's something called DevOps. We'll talk about DevOps later. But basically, the world of IT and the world of development is now becoming more and more synergistic, more and more one thing. So that now, if you're going to be a systems administrator, not only do you have to know, again, basic permissions and Linux and Windows and all that kind of thing, but you are going to have to understand coding simply to be able to get your systems to be able to work with things such as a serverless architecture from Microsoft Azure or from AWS, or being able to do basic scripting to do things such as notifications. So that's a basic idea of kind of giving you an idea of what programming is and why it's important now, especially from an IT operations perspective. Now that you have an idea, basically what we're talking about programming, coding. So basically we are giving instructions to computers. Perhaps it's for an invoicing system, perhaps it's for a video game, or perhaps it's to send it notifications if a temperature goes above a certain level. Then the next question that comes up that we have to gloss over a little bit is the question of, well, what's the best programming language? This sounds cool. I want to be able to tell computers what to do. Eli, tell me the best programming language out there. Well, the important thing to understand about programming languages is that there, frankly, are a metric crap ton of programming languages. A good way to think of a programming language is basically as if it's its own type of program, right? So, you have QuickBooks and you have Word. Well, an important thing to understand is that you most likely would not try to write a term paper with QuickBooks. You could, I suppose. Print it out on multiple invoice papers, right? But trying to write a term paper with QuickBooks is just a really bad way of trying to do things. The same is true with trying to create an invoice system with basically a word processor. I've seen some really cheap companies do it, and you get the mess that you would expect, right? Different programs do different tasks better or worse than others, right? They're built in order to do a specific thing. The same is true with a programming language. A programming language really, in a way, is a program unto itself. And so with programming languages, you will use the programming language that is most appropriate for the task or for the problem that you're trying to solve. So one of the programming languages out there is Swift. Right? So Swift is a programming language that is used for iOS applications. So if you're going to create things for iPhones, or if you're going to create things for iPad devices, you would use Swift. So if you're in the Apple world, if you're in the iOS world, and you need to create mobile applications, then Swift would be a great language for you. But the important thing to understand is that that application, that app that you create in Swift, you can't simply take that app and throw it onto an Android device. You can't necessarily throw that onto a server, right? You use a programming language for the environment that you're going to be dealing with. So iOS, the Apple world, you would be using Swift. If you're going to be doing things like Android devices, then you would use a language called Java. So Java is what you'd be using for Android devices and for other things. If you're going to be creating web applications, you may be using PHP, you may be using something called Node.js, you may be using something called Ruby on Rails, you may be using something called Python, right? There's a whole bunch of different languages out there. And they are used in order to basically solve certain problems, be able to do certain tasks. So one of the programming languages I like to teach people, especially that are new, is something called PHP. So PHP is what is called a server-side scripting language, and it's used usually for web applications. So if you're looking at something such as WordPress or Drupal, the programming language that's used to build much of that is something called PHP. So basically, if you're trying to create a web application, you may want to use PHP. So All I want you to understand out of this, we'll talk about the best language later and a little bit more. But the big thing to understand is when you're looking at these different programming languages and you're trying to figure out which is the best one for you, what you need to do is you need to look at your environment. You need to look at what problems you're trying to solve, and then from that, figure out which language you're going to go for. So again, like if you're in the Microsoft world, let's say you're in the Microsoft world, so you need to deal with the Microsoft stack. So when we talk about the Microsoft stack, we're talking about Active Directory, we're talking about those Exchange email services, possibly SharePoint services, different services that Microsoft servers have to offer. Well, if you're looking at that environment, you may want to take a look at C#. So C# is good for the Microsoft world, where again, if you're using AWS as your infrastructure, you may not want to use C#. You may want to use something else. So the important thing to understand when you're thinking about trying to figure out what programming language you want to start with or what programming language you want to use, look at your environment, look at what your requirements are, then go and do some research. From that, you can then figure out what is most likely the best option for you. Now, the next question that comes up is, what is the best way to learn coding? What is the best way to learn programming? Do you need to go off to college? Do you need to go off and spend $20,000 on a boot camp? Can you just learn it all yourself? The answer to that really comes down to you and what your situation is. You can learn things just piecemeal. You can go to YouTube. you can go on the web. You can learn things, right? Grab a couple of books. You can go through some kind of self-study program that's been created by somebody else. So if you look at something like Code Academy, that may be a way to go. They have specific programs on how to learn PHP and JavaScript and that type of thing. You can do a boot camp. Boot camps are valuable in certain circumstances, or you can go to college. And again, college can be valuable in some circumstances. The first thing that you need to really think about is think about why you want to learn coding, why you want to learn programming. Based on that, you will be able to figure out the best option for you for how to learn. So if you've just heard, all you've heard in life is that coding is something that you should learn, right? Hey, people who are coders, people that are programmers, they make good money. Right? If you're in that particular circumstance, I would actually argue college is probably the best way for you to go. Now, a lot of people out there be like, college is a horrible way to learn programming. That's just a waste of time. That's just a waste of money. One of the important things, if you're completely new, you really have no idea what code is, right? You're one of those people like, I want to do code because I want to do computers, right? I get those people. They come to me. They say, Eli, what's the best way to work on computers? I'm like, well, is that networking or coding or sysadmin? What is that, right? The problem is when you get those people that are so new, they literally know so little about the industry. It's very difficult to tell them what path that they should go on because, again, they really don't know. So one of the good things about colleges, whether it's an associate's degree or whether it's a bachelor's degree, is that you're going to go into college and they are going to give you a wide view of the industry. Now, let's be honest with you, it may not be the best education. But it'll be an eye-opening education. And that may sound a little snarky, that may sound a little weird. But again, one of the things you have to think about is what is the value? What do you need to come away from the education? And so when you go into a college program, they're most likely going to have a class on systems, right? So that class on system administration is going to teach you about, Windows, I don't know. Windows 8 server, maybe some old stuff, right? But they'll teach you about Windows systems administration. It may be 10-year-old Windows system administration, to be clear, but they're mostly going to teach you about Windows system administration. They're going to teach you about Linux system administration. Again, if you're going to go into any kind of computer science program or any kind of information systems program now, you're going to use Linux. On top of that, you're most likely going to have a networking course. So that's going to teach you about networking. And then on top of that, then you're going to start to get some coding languages. You're most likely going to start off with something like Java. Java is one of the basic languages, possibly Python now, whatever their introductory language is. And then beyond that, they're going to start to give you more and more classes, and you'll learn about things such as neural networks and storage and databases and all this kind of stuff, right? Now, a lot of people get snarky about this. A lot of people get mean because, again, to be clear, the education that you're getting might be 5 years behind the times. If you're lucky, the education that you're going to be getting is 5 years behind the times. And so you might be sitting there, you might be like, wow, I don't want 5 year behind the time education. But understand, you're going to be getting a wide view of things. You're going to learn about databases. You're going to learn about networking. You're going to learn about systems administration. You're going to learn a few programming languages. And then from that, you come out with a degree. So let's face it, a lot of employers out there like degrees. So you're going to come out with a degree. You're going to come out with a wide experience with a lot of these different things. And then from there, it will be much easier to figure out what you actually want to go for, what you actually want to do, right? You go into computer science, you go in, you say that I want to learn coding. And then maybe you figure out networking is the way you want to go. Or you may figure out something else, right? So that's one of the values of going to college. Not only that, one of the things that I like with college, especially with new people, is that it takes you a while to go through. One of the worst problems with things like boot camps is frankly how quick they are. You look at it, you go, wow, boot camps are quick. I want to do a boot camp. 3 months, 4 months, I'll come out and I'll know how to do X, Y, or Z. One of the problems with boot camps is they can be too fast. You rush through, you learn everything. Let's say you actually do learn everything. Let's say it all goes into your head, it's all great. One of the problems is they push you out after 4 months and it's been so quick. You haven't made any contacts in the field. You still don't know what companies are hiring in your area. You're still not really sure how to write a resume or any of these other things. So you got all this information shoved into your head so fast, but then you come out and you're not really sure what to do with it. And then if you can't get a job in a month or 6 months or a year, this is something that I see happens, where you see people that can't get a job in a year, and then all that information that they learned in the boot camp starts coming out their ears. And then one of the questions is, how valuable is that? One of the nice things with going to, let's say, a 4-year program at college is you go, you learn a couple of things, and then maybe you can get a help desk job, or you can get an internship. You can volunteer somewhere. And then as you're going along, maybe you can step up, maybe like get a little junior sysadmin job, maybe part-time job, and then you can step up and then you're working and you're actually doing things and you're meeting people and you're talking with friends to see what their companies are like. And basically it gives you 2 to 4 years to actually figure out what the overall industry looks like. So that's one of the big values with going to college. Not only that, you pay all the money, but again, you do actually come out with a college degree, and at least for a little while, employers like the college degree. If you don't want to go through all that for whatever reason, you might take a look at boot camps. Now, boot camps are really good, I would argue, for professionals that are basically simply trying to retrain. So let's say, oh lordy, let's hope it never has to happen. Let's imagine I had to go out and get a real job again. Let's imagine I'm not getting paid for sitting in front of this camera. And so I had to go out and get a real job again. I've been doing technology since 1996. I've dealt with military systems, Windows NT4 way back in the day, telephone systems. I've talked in front of a camera. I've done all these things. Well, remember, you get hired to perform a certain task for a company. It's not about the experience you have. It's not about what you've done. It's about what you can do for a company, right? So if I had to go out there and I had to get a pretty decent job and I wanted to actually work with my hands, a boot camp might be a good idea to get me up to speed on a specific language. So let's say I've been doing everything that I've been doing. I sit there and I go, ooh, I really like iOS. Again, I'm an Apple fanboy. I really like iOS. So I'm going to jump in. I know the technology field. I know networking. I know all this stuff. I know the money is in iOS development. So I really need to learn Swift, and I need to learn Swift fast. Well, it may be valuable for me to go to a boot camp because in anywhere from 3 to 4 months, I can jump in. I already know what the industry looks like. I already know what kind of jobs I'm trying to go for. I probably already have contacts and feelers out there that say, hey, once you know how to do X, Y, or Z, we'll be happy to hire you. So I can jump into a boot camp, pay $15,000 to $20,000, and frankly, it doesn't matter because the amount that the companies are paying right now for people that are able to code in certain languages, I can pay that off relatively easily in a year. So what I would argue is for people that already are in the tech industry or really, really know they want to be in the tech industry. Let's say you're 18 years old, you've been doing coding for the past couple of years as a high school student, right? You've been playing around with JavaScript. You've been hacking. right? You really like, you like technology, you like coding, but the problem is you're not really sure how to put what you know into the context of what a job would require. Again, that's a really big problem. Again, that might be a place for a boot camp. You already know you like technology, you're already messing around with this crap for 6 hours a day anyway, so a boot camp will basically be able to focus you on what you need to know and what you understand and actually give you something that you can put on a resume. I think that is valuable for a boot camp. I will caution a lot of people out there, a lot of noobs out there, it pains me to see this, it pains me, is a lot of complete noobs. Again, those people that want to work on computers. Computers! What do you want to do? Computers! Oh, right. Sadly, a lot of those folks jump into things like boot camps. And one of the problems you run into when you jump into one of these boot camps is you may not actually want to be a tech professional. This is one of those things that these boot camps never talk about, is how many people who go into your boot camp actually want to be tech professionals when they walk out the other side. Right? And this is not being snarky. It's not about being smart. It's not about being better or being worse. The fact of the matter is being a tech professional requires a certain personality type. It requires a certain mentality. It requires a certain personality type. It requires certain things. Again, in order to be a park ranger, right? To be a park ranger requires a certain personality type. You have to want to be out in the air. You have to not really care about getting bit by mosquitoes, right? There's a lot of things. If I told you that you had to have a specific personality type to be a park ranger, people would think that's completely normal. That's obvious. Yet when I say the same thing about being a coder, they look at me like I'm a moron. But it's the same thing, right? To want to sit down and deal with computers day in, day out, to deal with the users, to deal with the bosses, to deal with the environment, it requires a certain mindset. And one of the big problems I see with noobs is that they jump in, and it's not that they're not smart, and it's not that they can't keep up, and it's not that they don't understand, but they don't really want to do it, right? They go through their 3 or 4 months, they pay their $20,000. Again, nobody's getting screwed. Nobody's getting ripped off. They learn the material in the amount of time, but then they come out the other side and they don't really want to do this job. And so that can be a really big problem. So that's why I caution people jumping into boot camps if they don't have experience or if they don't know they really want to be in the tech industry, because you can run into that problem. Then we go to the self-study programs. I would argue for most people, self-study programs are probably the way to go. So when I'm talking about self-study programs, things like Code Academy, I think lynda.com has stuff now, Coursera, right? There's a lot of self-study programs out there that are great. You pay $40-50 a month. They have something slotted out for you. They basically have a curriculum for you, and then you just go from the first part to the next part to the next part to the next part. And I think it's a really good way to really get into to start learning about programming, to start learning about this world, because it does give you a format. It does give you an outline to follow, but it's not going to cost you a lot of money. Again, if you do it for a couple of months and you don't like it, you're out $120 and however much time you put into it. But I think that is a good way for a lot of people to start. One of the only problems with that is sometimes, again, if you're a professional and you need to actually know something, how to get something done now, that can be a little long and a little tedious. You may find in order to figure out the function that you need to use, function is a term in programming, we'll talk about that's later. But let's say you need to understand how a particular function works. If you do step by step through one of these self-study curriculums, it may take you a while to get there. That's where you can also simply learn how to do coding piecemeal, like completely and utterly piecemeal. This is one of the secrets about coding. You can actually create code that you can put into a production environment and not be an expert. One of the great things about coding in this modern world is coding has gotten relatively simple, especially with something called scripting languages. We'll talk about in another class, where basically you can write 10 lines of code that can be shockingly powerful for your organization. So again, let's say you have a server room. Let's say you have a server room and you're really worried about if the server room overheats and what damage that'll do to your equipment, right? So all you care about, you don't want to be an expert. You don't want to be an expert. You just heard, hey, with these little Arduino microcontrollers, I can add sensors to these things, and then I can have this microcontroller be able to communicate up to a server or be able to send out an email on its own to alert me when there's a problem. So I don't want to be an Arduino expert. I don't want to be a node expert or anything like that. I just need to know temperature above a certain level, send me email. You can literally go online and you can figure out, it's like, okay, this is the Arduino. You can grab some snippets of code here. You can grab some snippets of code here. You can basically duct tape it all together. You can test it 50 or 60 times, realize it does what it's supposed to do. Yay! You created code for a production environment. So that is one way that you can go about learning how to code, is again basically looking for how to get computers to perform specific tasks for you. And again, if all you care about is a couple of things, you can basically do a lot of copy and pasting, put it all together, and within a day or so, you may actually have something that is very useful for you. So those are the different ways that you can learn to code. Again, college is great for some people. If you have no idea what the hell you're doing, you're not in the field, you're probably pretty young when somebody asks you, what in technology you want to do, you say computers. College is probably a good way to go, because at the end of it, even if you decide not to work in computers, you still have a degree, right? A degree can get you a manager's job. A degree can actually get you a higher value job than you may be able to get if you come out of a boot camp and you decide you don't want to do computers anymore, right? Degrees, good or bad, actually look good on the resume. Boot camps, I think boot camps are very good for tech professionals. If you are a CCNP, if you are an MCSE, if you've been in the field for 5 or 10 years, you realize your skills are becoming obsolete. Not all technology skills are valuable forever and ever, right? You realize that basically your resume is about to expire. I think going to something like a boot camp can be a very good thing. Again, you're in a Microsoft environment, you're looking around going, wow, MCSEs are not as valuable as they used to be. But again, being able to write code on the Microsoft stack, being able to connect Exchange and Active Directory and all these things using something like C#, that is valuable and will be valuable for the next decade. So I'm going to go to a boot camp to learn C#. I think that is a very useful thing. I think it's a good way to go. Again, the self-study programs, I think for most people, that's a good way to jump in. The only problem you're going to have with self-study programs is your own self-discipline. Again, itself, you have to sit down an hour a day to do the work. If you don't do it, it's going to be a problem. And the other thing, again, if you're a professional, if you're looking at self-study programs, is you're going to go through all these steps. So to learn what you need to learn, you may have to get 20 hours in the program. So one of the things that you might do is just simply piecemeal work. Again, you just go out there, you copy and paste, you look at a couple of YouTube videos, you slap some things together, you put some duct tape on it, and you'll be surprised how powerful little applications you can build with surprisingly little knowledge and little time. So those are some of the different ways that you can learn to code in the real world. So the next thing that I'm going to talk about might horrify some people. So a lot of wannabe coders out there, they want to be coders because they don't like people. They're like, hey, I don't like people, but I like making money. What job allows me to make money and never be around people? And so they have the idea that coding is the way to go. And in some circumstances, that can work out for you, especially once you know what you're doing, once somebody can give you a task, once they can give you an assignment, and they know 2 weeks from now you'll give them a result, you'll give them a product, then possibly at that point, then you can lock yourself up in some cabin in the woods and not actually deal with human beings. But when you're new, it's going to be very important to get around other coders. And the reason is the basic reasons, again, in any kind of business or any kind of professional development. The first thing is you're going to need to find companies that actually want to hire you and hire somebody of your skill level. Do you remember, if you go to Indeed, if you go to Monster.com, if you go to any of these job boards, one of the big problems is when somebody puts out a job posting, they're going to get hundreds or possibly thousands of resumes of people wanting that job. And so for the people putting out those job postings, one of the first tasks that they have to do is go through and basically delete anything that doesn't look like they're people that they want to hire. And so when you're very new, one of the big problems you're going to run into is, frankly, the first thing that's going to happen whenever you submit a resume is the person you submitted the resume to is going to delete your resume. Why? They've got 100 or 1,000 resumes to get through, and yours is probably the least significant. So one of the important things, if you go out there and you start meeting coders, you start meeting with companies that are hiring coders, then you can meet people face to face. And basically what you really should try to do in the technology world when you're trying to get a job is basically you should get a job before the job posting goes out, right? You go to meetups, you go to tech events, you're talking with people who say, hey, yeah, I've been spending the past 2 months learning Python or Node or whatever else. I'm trying to get my foot in the door with a company that does those programming languages. And they go, wow, you know, we need another developer, and we're willing to hire somebody that's low level because we're so desperate to get a developer. Hey, let's get you in for an interview tomorrow. Right? That's the way to get a job. So the first reason that you're going to need to go out there and be around people is simply that is the best way to get a job. Go to meetups, go to tech events, talk with folks, and you'll be surprised how many jobs are out there. And again, you're sitting there with a beer, just shooting the crap, talking about the world, talking about the little projects that you're doing. That is the easy way to get a job. You're sitting there talking about the projects that you're doing, then the person's like, oh, that sounds interesting. We need somebody that actually knows how to do that. I don't suppose you're looking for a job. You go, why, yes, I am. That's a hell of a lot better than sending out resumes to 1,000 different companies. And the people, the first thing they're going to do is delete your resume. So the first reason that you need to be around coders and basically people in the field is to get the job. The next thing the reason that you need to be around people in the field is to see what kind of code they're writing, how they're writing code, syntax, and all those types of things. One of the big problems in the coding world is something called a spaghetti code or garbage code, or crap that shouldn't be called code. Here's a weird thing about coding, right? You can type code that works perfectly, but looks like hell. Looks like absolute trash, right? The computer understands what you're saying. No other human being in the world does, right? And so one of the problems is, again, especially when people self-study or they're going through these self-study programs, is when they're learning to code, they learn how to do things technically right. But again, in a professional environment, when you're dealing with other people that are going to have to look at your code, they may not know what the hell you're trying to get at. So one of the valuable things with being around coders, again, going to meetups, going to tech, basically programming meetups, seeing how other people write the code, is then you can see how people write the code, especially in your area. See what the syntax is, see how they do commenting, see how they do documentation, see how they write things, so that you can then make your code look more appropriate within the professional environment that you're going for. So that's one of the things. Then finally, one of the valuable things with going out there and meeting other coders, basically again going to meetups, tech events, and that type of thing, is you can try to find projects to work on where they may not even be paid, right? So nonprofit organizations, startups. Startups are a great place to get experience. They have no money. Most of the founders don't know what the hell they're doing. You can hand them a brick and they'd say, thank you, right? But, right, so there's a lot of startups out there. There's a lot of startups out there that are trying to create the next dog dating app or the next Facebook, right? And they don't have any money and they need to get something out. And so one of the things is you can go to them and you can say, well, you know, I've been working with Python or Node, whatever, Swift, for the past few months. I would be happy to try to get a prototype, try to get a minimum viable product of your idea off the ground. Now, you may not get paid, and to be clear, the equity is most likely worthless. Most likely, who knows? Maybe it's the next Facebook, probably not. But, right, you can work with a startup, you can be talking with people, you can be communicating with people, you can start to get the experience of what is required to take somebody else's vision and turn it into a product. The end result is probably going to be a horrible mess, but you will have gained the experience, right? And so that's something to be thinking about. Again, like nonprofit organizations, a lot of times they need rather simple applications to be created. Again, mailing lists, news blast systems, that type of thing. That's something that with about a month's worth of experience learning how to code that you could actually create. And then you are creating projects for organizations and companies. You're learning what the process is, so on and so forth. So it's very important to be around coders. Coders, business people, the whole 9 yards, whether you go to tech events, whether you go to meetups, things like that, because you're going to learn about jobs. You're going to learn about the jobs that aren't necessarily out there on the job boards. You're going to get to talk with people, which is the best way to get a job, not simply submitting a resume. You're going to be able to see, again, how people actually write their code, how to make code not just function properly, but also look pretty, which is very important. And then you can be around people, see what projects that they need help with. And again, even if you don't get paid, you can get some experience to actually allow you to figure out how coding works in the real world, so that when you do get that first job, your life will be a lot easier. Now, the final thing that I want to talk about is your need for motivation if you want to become a coder, if you want to become a programmer. So I have sat down and I have interviewed CEOs and owners for many development companies. And whenever I sit down and talk with them, I always ask, what are you looking for out of a new coder? If you're going to go out there and going to hire a coder, are you looking for a certification? Are you looking for a degree? What is really the important thing that you're looking for? And the thing that all the CEOs, all the owners come back and they tell me is that they're looking for the projects that the interviewee has done, right? So the big thing that these folks are talking about is that they're looking for people that have motivation. They're looking for people that have discipline. They're looking for people that can see problems and then be able to write code to solve the problem without having to be told exactly what to do. So this is a big thing in the technology world, is we are not generally micromanaged. Somebody is not sitting over our shoulder telling us exactly what to do, right? If you're a cook, right? If you're a cook, if you're a sous chef or something, somebody is most likely looking at what you do all the time and, smacking you whenever you do something wrong. If you're a lot of other types of jobs, you're micromanaged and people know what you're doing and they will be able to correct you very easily if you do something dumb. One of the things in the coding world and the technology world in general is that generally people are not looking over your shoulder. You're given a task and you're expected to complete that task, and then hand the completed product. That completed product, it'll go through the quality assurance, hopefully. Hopefully it'll be audited. Hopefully somebody will look at what you did. Hopefully, but that is actually a hope. That is a hope, right? But the idea is you are given an assignment and then you're expected to complete that assignment, basically hand back the results. So one of the problems a lot of these CEOs, a lot of these owners of these development shops talk about is that they get people that know how to code, but they expect to be handheld. Like, when I get to, somebody's gonna hold my hand and tell me exactly what to do. And what these folks say is, that's actually not valuable to us. Knowing the language is not valuable at all if I have to hold your hand. They would actually prefer somebody with less experience, somebody with less qualifications, that when you give them an assignment, they just do the assignment, they run with it. Because that's the thing, right? If you're given an assignment and then you could complete the full assignment and then they're sitting there looking at what you did, it's a lot easier for them to say, you need to put some more comments in here. Oh, see this function right here? I get where you're going with this function, but for us in our environment, this is how we would prefer to solve the problem, right? It's a lot easier for them to go in and basically proofread the code that you've written versus step by step. Okay, you need to create these variables and you need to use these specific functions, and then if they have to explain all of that to you, they literally might as well write the code themselves. So what these folks are saying is they want to see what projects you've done, whether they're projects for businesses, what projects you can talk about for businesses, whether they're projects for nonprofits, or whether they're your own projects, right? So if you're going out there, you see something interesting, you're like, I wonder if I could create an application that would do X, Y, or Z. That's the type of thing that they want to see. They want to see your own motivation and that you're actually doing projects and things on your own. I was talking with a recruiter one time, and he said that was one of the worst problems with boot camps. He said GitHub. So GitHub is a place where you can put all your codes. You're doing projects. You put all your stuff onto GitHub, basically do collaboration, that type of thing. And he said one of the biggest problems with a lot of the people that he was dealing with is that while they were in the boot camp, they were posting all this stuff to GitHub. And then you could literally tell the day they graduated from the boot camp, because that's when there was nothing else. Right? And so again, think about it if you're a boss, if you're a manager, if you're going to be hiring coders, right? Do you want to hire somebody that only does work while they're in boot camp and then does literally nothing else afterwards? Or do you want somebody that goes through, and again, every couple of days, every week, they're adding to GitHub, they're adding to their little projects, they're learning how to do new things, and you go, oh, okay, this person is actually interested in it. This person has the mindset to be able to see a problem, to be able to try to figure out a solution for the problem, and then try to be able to implement that solution. So that's the types of things that these owners, the recruiters, the CEOs and such, that they're actually looking for. Is they're not looking specifically for the certifications. They're not even specifically looking for the degrees. For the most part, they're looking for people that are actually out there using code to solve problems. And so it's very important, even if you don't have a job, even if you don't have going through college or anything like that, actually create applications. If you're learning Swift, right? So Swift is for iOS, it's for iPhones, iPads, that type of thing. Actually create apps. Don't just learn it, create apps. Try to get it onto the Apple Store so that it can be downloaded by other people, so that these people that are hiring can say, okay, this person is motivated enough, they're interested enough, they're actually able to solve problems that they see. This is somebody that I can teach to do something valuable. So that's one of the final things you need to be thinking about, is that, again, with code, it's not simply about understanding having the technical ability to do code. It's that you're actually motivated, self-motivated to go out there and do it on your own. So there you go. That was just a little class for some of the things that you need to be thinking about if you want to learn how to program, learn how to code, especially if you want to do this professionally. Again, a big problem in the real world is you have a lot of these noobs that basically say, I want to do computers. They have no idea what that actually means. And again, if you don't really understand what's going on, it's a little bit complicated to learn what's happening. Again, one of the important things that I would say, if you're a systems administrator, again, sysadmin, you do Linux, even if you do things like networking, coding now is more important than ever. I remember 20 years ago when all you knew was Windows. If all you knew was Windows NT4, NT4 server, NT4 client, you could get a very good job, and that was it, right? You didn't have to know Linux, you didn't have to know command line, you didn't even have to have a CCNA. You could just know Windows NT4 and you could get a good job. As time went by, then you needed to know networking, right? Anybody who's doing sysadmin who doesn't know DNS and DHCP and basic routing, subnets, and that kind of thing, well, they're not valuable. So then people started to learn that. And then as time went by, Linux became more prominent, more and more Linux servers. Why are you going to deploy a very expensive Windows file server when you can simply spin up a Linux box for almost no money? So then, again, sysadmins and all that, then they started having to know Linux. Beyond that, then so many people started to use Macs. So now if you're doing sysadmin work, you probably have to know how a Mac works too. Well, again, basically, as time goes by, even if you're doing IT work, you're having to learn more and more and more technologies in ways that you didn't have to before. And now we're getting to the point where, just like 10 years ago, you had to learn Linux in order to stay relevant. Now you're going to have to learn some level of coding to stay relevant. Again, whether it's doing basic scripting tasks for your servers. Again, there's a lot of automated management software out there where, in order to do the automated management, basically you have to write out basically looks like programming in order to get it to work. Whether it's doing IoT devices, getting IoT devices to communicate, to do notifications and that type of thing. Whether it's, again, you're doing something more sophisticated, you're going to be dealing with cloud functions. Again, the service-oriented architecture, the serverless architecture world. Again, you're going to have to learn coding simply just to keep up. Coding is no longer a skill that, it's a nice to have. going into the future, it's going to be a requirement, right? Now, if you're doing system administration work and you don't understand Linux, you're behind the times. Well, it's like, what? You're a systems administrator and you know nothing about Linux? That seems ridiculous. Now it's getting to the point, the same is true with coding. If you can't do basic coding tasks, you're going to become ever more irrelevant. So now coding is just one of those tasks, along with understanding how systems work, that everybody should know. The best language that you're going to need to learn really depends upon what your environment is. Again, if you're dealing with iOS stuff, maybe you're going to need to learn Swift. If you're dealing with, again, cloud functions, Azure functions, maybe you're going to need to learn Python. Depending on your infrastructure, maybe you need to learn something like Node.js or Java. The best language is the language that will solve the problems that you're having. In order to learn coding, programming really depends on where you are in your career and what you understand. Again, college is good for a lot of people. I know a lot of people nowadays are really snarky about college, but the truth of the matter is, if you really have no idea what the hell you're doing, if your answer is computers, probably going to college, right? You go to college, you can learn about networking, you can learn about systems, you can learn about this, you can learn about that, you can learn about the other. Maybe, yeah, let's admit it, maybe some of the information is about 5 years old, but let's face it, variables are variables, functions are functions, if-else statements are if-else statements, right? It's not, like, classes are classes. Classes is something else in programming. Right? Yeah, the information you're getting might be a little bit old, but a lot of what you're going to learn is going to continue to be relevant. Again, if you go to a class on databases, possibly you're learning about an older database in your college class. But again, if you understand a relational database, most relational databases more or less look the same. So it's a lot easier to learn a new product once you have a good basis. And beyond that, if you decide that you do not want to continue in the technology world, you're gonna have a degree. The fact of the matter is, right or wrong, right now, degrees are still valuable. So really think about the college. Again, boot camps are good. If you're already professional, you need to ramp up to know a coding language. You know why you need to know it. You possibly already have job offers on the table. Once you know it, boot camps are a great way to go. But you do have to be careful if you're a noob. Because again, if you come out and you don't get a job for a year, all that information goes out your head. There's self-study programs, and you can also learn things piecemeal, as I talked about before. And then you need to be thinking about how you're going to go out there and you're going to meet other programmers. Again, this is important. A lot of programmers are kind of like shy people. They don't want to be around people, so this can be a big problem, right? In order to get a job is an interpersonal, exchange, right? You have to find people that are willing to hire you. You have to have an interview. Those people actually have to like you enough to hire you, right? All that stuff. And so it's very important. Go out to meetups, go out to tech events, meet other people, talk to other people, see what experiences they have, see if they know what companies are hiring and what's being required, right? Just go out there and have those conversations. While you're doing that, see if you can pick up some side projects. Again, startups have no money, their equity is worthless, but hey, you can hand them a brick and they'll probably say thank you, right? Go talk to these startup founders. See if you can actually offer them something. It gets you experience. And they don't have any money anyway, so it's a win-win, right? And the final thing really to be thinking about is that realize when you go to get hired by these companies want to see what you have actually done. Again, whether it's preferably it's paid work, right? Preferably you have paid experience. But if you don't have paid experience, what have you produced for nonprofit organizations? What have you produced for startups? What have you produced on your own? If you've learned Swift or if you've learned Android development, do you have things on the Google Play Store? Do you have things on the Apple Store, right? That's the type of thing that's really important to them that they want to see, because I've talked with them time and time again, and they say one of the worst things in the world is to hire a coder that needs to be handheld, because that's just not how it works. Like, again, if they have to tell you every variable that has to be created, every function that has to be used, every if-else statement, by the time they explain all that out to you, they could have typed the code. So why are they hiring you, right? So they're looking for people that have that self-motivation to see a problem, be able to figure out what a solution should be, and be able to actually create a solution. Even if that solution is ugly and nasty and all that kind of stuff, they can help edit that. They can go through and tell you how things should be better so that you do it better in the future. It's better to have somebody highly motivated that may not have the best skill set than have somebody with a great skill set that isn't motivated. That's one thing I've heard from a lot of the people that are actually hiring coders out there. So with that, that's just a basic introduction to the programming coding world. We're going to have many more classes on this introduction to programming track, and then we're going to have other specific tracks. I already have a specific track on PHP and PHP with MySQL. We will have more specific tracks in the future on different programming languages, but this is just a basic introduction overview to give you an idea of what's going on in the programming and coding world. As always, I enjoy doing this video and look forward to seeing the next one. Apparently, the type of content you just saw is not what Susan W. wants for the future of YouTube. This means that recommendations by YouTube to this channel have dropped massively and views are becoming comically small. I hate to ask. I used to say I would never ask, but if you could subscribe, like, comment, and most importantly, share the videos that you appreciate, that may help slow the death of this channel. Do remember that if anything at all happens to this channel, you can go to EliTheComputerGuy.com to view the content and access information not available on YouTube.